Okay, let's go ahead and take a look at the next problem. They're asking us to find V of X using Ohm's law, KVL, and KCL. So if we take a look at what's going on here, we see that V of X is actually the source. So what we'll need to do is look at what else we have. We have 1 amp down here, and then we have 4 resistors, 1, 2, 3, and then 4. And we'll see that our current will leave here, travel this way, drop down, break up, go that way, travel back around here, and go back up and meet that way. So that's how our current's going to break up. So I'm going to give these names. I'll call this one I1, I'll call this one I2, and I will call this one I3. Okay, so let's see what else we know about the circuit. We see that these 3 are in parallel with each other. That could be useful for us. And what do we know about parallel branches? Well, we know that parallel branches have the same voltage drop across them. So we know parallel has same voltage drop. So with that knowledge, if we could find the voltage of one branch, we could find the voltage of the R parallel. Well, it just so happens that we have all the information we need to find that. V is equal to IR will tell us what the voltage is across that 5 ohm resistor. So we know it's 1 amp here, and we know that there's 5 ohms. So we have 5 volts here. Great. And since we know that there's 5 volts dropping here, and since this is in parallel and this is in parallel, that's all going to be 5 volts. And we have a couple options. We can either go ahead and do a voltage division with a loop, or what we're going to end up doing for this problem is to combine our resistors in parallel. So R parallel will be 1 over 5 plus 1 over 5 plus 1 over 10. So this will give us 2. And if we come over here and draw it again for us, where this is R parallel, this is 5, this is V of X. And we know from here to there, there's 5 volts across it. We can do a couple things. We can say that, and we know that also that this is 2 ohms. So we've got a few options of what we can do. We can say that, well, since we know the voltage and the resistance, we can say I is equal to V over R. So this would be 5 over 2, and that would give us 2.5 amps. That can be useful for us. So now we know the current that's going that way. So we can do this where we say if we know there's 2.5 amps traveling through, we know the current and we know the voltage, the resistance, we can find the voltage across that. So we can say the voltage across the 5 ohm resistor is going to be 2.5 amps times 5 ohms should give us 12.5 volts. So if we know that there's 12.5 volts here, and there's 5 volts there, and we're going to assume there's 0 volts here entering this battery, and we assume that all of our voltage from our battery is lost to our resistors, we can add those two voltages together. So plus 5 volts, and we'll get 17.5 volts is equal to V of X. I'll write it out here as well in the KVL format. So if we did negative V of X plus 12.5 volts plus 5 volts is equal to 0, V of X is equal to 17.5 volts. All right. And just knowing that information helps us out a lot. Knowing that is the first step. And then knowing that we can just go ahead and solve for the current through everything helps us just piece everything together to where we can get to that point.